In this video, we're going to talk about longest common subsequences using dynamic programming. If you would like to see this using the elegant but inefficient recursive algorithm, see the previous video. This will be a inelegant, very efficient algorithm. That's the computer science trade-off. So, what are we doing here? We're going to take two strings, build a matrix that's roughly the number of rows equal to the length of one string, the number of columns, the length of the other string, plus one for each dimension. So we're going to have this nice little padding up top here. And we're going to have this padding on the left. So for strings of length 2 and 2, this little 2 by 2 matrix in the bottom left is going to be the actual matrix. The left first column and first row will always be padded 0. So we're basically going to start here. For all intents and purposes, this is the index 0, 0 into this array. We're going to pretend the padding doesn't exist for now. And we're going to check, does A equal T? So here's our first string, AT, here's TT, so A does not equal T. So we're going to say this value is going to be the maximum of whatever's above it and whatever's to the left of it. They're both 0, so we keep 0. Okay, now I0 j equals 1. We're going to say T does equal T. So we're going to take the northwest diagonal value and add 1. So northwest is 0, 1 plus 0 is 1. Okay, now we go here, the 1, 0 index. A does not equal T, so it's the max of 0 and 0, that's 0. And here, T equals T, so we're going to take the diagonal plus 1, which is going to give us 1. So anytime you want to know the longest common subsequence, it's the bottom right, or the length of the longest common subsequences. It's the bottom right element of this matrix. So this says it's 1, and that's true because the longest common subsequence of AT and TT is T. Pay no attention to this. Okay, so from last time, we have this little function. It's going to generate some random characters. The default is string.ascii uppercase. This will be A through Z uppercase. But for this demo, we're just going to be using these 4 biological letters. So let's see what we have so far. So right now, we just have a function that generates a lot of random strings. Okay, and what are we going to do with this? We're going to write a function. Okay, so it's going to take lists, arrays, whatever you want to call them. Let's just call them lists for now. So to create that padded matrix, we're going to do this. 0 for j in range, length b plus 1. For I in range, length A plus 1. So just to see what that looks like, let's print it. A not defined. Okay, so this is a matrix. Let's make that look a little better. Okay, that's a much better looking matrix. So now we have the initial matrix, and we need to do a few things. We need to iterate over all values in A, and all values in B, and we need to check x equals y, then matrix I plus 1, j plus 1 equals the northwest diagonal, ij plus 1. Those of you who don't know what enumerate is, when you pass enumerate a list, it returns, I think it's a generator of tuples, or a list of tuples, where this is the tuple, and the first value is just the index of the list, and the second value is the value of the list. So I is going to be 0 through length A, and x are just going to be the different values of A. So this is just a Python convenience. Okay, so if they're not equal, I'm going to do the max of whatever is above it, and whatever is to the left of it, I think. We'll see. Okay. So once we have that built, we need to read subsequence out from the matrix. So hold our result here. And we're going to start on the bottom right. So when we say ling A, ling B, we're saying we're going to start right here. And then we're going to go through the values and go up or down. And when values change, we're going to take the element and add it to this result. So there are 3 cases here. If matrix x, y equals matrix x minus 1, y, we're going to decrement x. If matrix xy equals, okay, so this is to the left, this is to the up, so we're going to decrement that, else result is going to be whatever value made the change, which means wherever there was a match, plus the result. So at first this is going to be an empty list, so we're going to be adding a list of length 1 to an empty list, which will give us a length of list 1, and then we'll add a list of length 1 to a list of length 1, that'll give us a list of length 2, and so on. So let's return the result and the matrix. And hopefully this will work. Nope. Okay. I forgot this equals sign. Okay. This return statement. Okay. So for this example, this is your A string. This is your B string. And we can see on inspection that AG is here and AG is here. Although for the longest common subsequence problem, it's not required that these two are contiguous or adjacent. If this G was here, the result would still be AG. Like if these two were swapped. If the C was here and the G was here, it would still be this. So if you look at the bottom, it's linked 2. You get the result. And let's run this on a little bigger set. Say 10. See how fast that was? So, longest common subsequence is length 5. This is the actual subsequence. And if you pause and look, hopefully you'll be able to find those in both of these. So this is kind of a nice little pattern here, zeros, ones, twos, threes, fours. So I went ahead and printed some stuff. If anyone here likes pictures, I've got, let's see. Here we go. So this is for length 50 by 50. Blue is 0. Red here is 13.5. So you can see that. Let's get a bigger one. So this is also the 4 letters. Oh no, this is A through Z. So this is 26 letters randomly of length 100. So it's 2 sequences of length 100 randomly pulled from A through Z. We'll go look at one more. This is for DNA, just 4 characters possible. And it looks a little smoother, but the shape's also a little different. When you change the number of possible characters you can use, you change the shape of that.